welcome back to part 2 of the MCQ. So same thing, please do it before or after you watch my solution to each MCQ question. All right, there's really no point just watching it if you don't want to try it out yourself. Okay. All right, so question 11 to 20 for this video, MCQ ZhongHua N-level paper. All right. So I've got three diagrams, which particles represent the arrangement in liquid and gas respectively. Okay, arrangement in liquid would be this fella. This one you have to know it. So let's put the X, and gas would be Y. Yeah. So therefore, the only thing that has two ticks is D. So the answer for question 11 is D. Let's go look at question 12. All right. So this is a temperature time graph. It's a cooling graph. Liquid of a liquid as it changes to solid. All right. So I know it starts off as a liquid and it ends as a solid. Okay. Which of the following describes the state of L and the change in state in kinetic, potential, and internal energy between Q and R? Okay, so between Q and R. Okay, so we are looking at this point, Q and R. Okay, so change in kinetic energy between here, there is no change. There's no change because the temperature stays constant. Okay, so kinetic energy is related to temperature. Just remember that. So if the temperature doesn't change, kinetic energy doesn't change. All right. But the potential energy decreases. The potential energy decreases. Yeah. And the internal energy therefore decreases. Okay. So therefore the answer is A. Now, potential energy decreases because it is still losing heat. It is still losing heat during this period of time, and therefore the total energy also decreases as well. It's still losing heat. Okay, next question 13. I've got a boiling water. The outer surface of each side is different. So I've got 1, 2, 3, 4 sides. Which side will lose heat? Will the heat loss be the slowest via infrared radiation? So I want a bad emitter of radiant heat. So black is out. Black is a good emitter. So I cancel off the blacks. Yeah. So this two is out. So now I've got to compare these two. Yeah. White is a bad emitter, which is what I want. Now I got to compare the surface here between shiny and dull. So shiny is actually a pretty bad emitter. Yeah, it's a bad emitter. Dull is a good emitter. So I do not want anything that is good at emitting radiant heat. I want something that is shiny and white. Okay, so shiny, white is the answer. Let's go on to question 14 now. Okay, so which of the arrangement will produce convection currents in the water? A lit lamp here means this part will be hot, okay? And since the hot water is already on top, it can't go up anymore because it's talking about in the water, not the air. So this will not cause the hot water to go down and so on and so forth. Okay, so the hot water just stays here. Electric heater, current through an electric heater. So when this fella gets heated up, the water over here gets heated up and therefore it will rise and cold water will sink. So yes, this seems to create some sort of convection current. Ice Ice on top will create cold water. Maybe I'll change it to a blue color here. So blue, cold water sinks, and therefore the hotter water will rise. So yes, a convection current will also appear here. And for part D, a candle flame, this part of the water gets heated. So yes, convection currents will be created. Okay, so I'm looking at 2, 3, and 4. So this would be the answer, 2, 3, 4 here. Okay, 16. So this chart shows the EM spectrum uh, in ascending order of frequency from left to right. What is X and Y? So this one I've already taught you. X is your infra. Now I was looking at microwave, but they don't seem to have a column for microwave. So straight up goes to infra because this fella cannot be X-ray. Okay, Y. So let's do Z first. Yeah, Z. So we got to compare these two. Which one comes first? X-ray comes first before gamma, right? So it is here. So therefore the answer is C. Okay, so they are kind of testing you the order of the EM spectrum. Remember the full order is radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma ray. So you have to remember the EM spectrum in this order with an increasing frequency here and an increasing wavelength in this direction. Okay, so you have to know this. Next, 16. Which of the following best defines the EMF? Okay, EMF is talking about work done. So I'm looking at this too. By the source to produce a current. No, so this one is C. So you have to remember the definition of the EMF. Okay. 17. I've got these two fellas connected in parallel. What is the effective resistance? So effective resistance is 1 over RT, now of a parallel circuit, yeah? Plus 1 over R1 plus 1 over R2. This fella is 1 over 2 plus 1 over 3, 1 over RT. Yeah, so 1 over RT is equivalent to 1 over RT equals to 0.833. And don't forget, over 1. Don't forget, I do not want 1 over RT. I want RT. So I have to invert my left-hand side. And what I do on my left-hand side, I have to do on my right-hand side. So RT over 1. And this gives me 1.2 ohms. Okay, so the answer is B. Next, I have a length of wire 0.4 meters, cross-sectional area of 0.2, resistance of 2. Now, same material, but this time the length is 3 times the original. Okay, it's 3 times the original, and the cross-sectional area is half of the original. Yeah. So what is the resistance? So let me settle the length first. When the length increases, the resistance increases. When the length increases by 3 times, the resistance increases by 3 times. So now the resistance is 2 times 3 ohms. Yeah? So this is the resistance so far based on the increase in length. Now, the cross-sectional area has decreased from 0.2 to 0.1. When the cross sectional area decreases, the resistance also increases. Okay, and if the cross-sectional area decrease by 2 times, the resistance will also increase by 2 times. So therefore, now I'm going to bring this value over here. I already have 2 times 3 here. I have to increase it by another 2 times. So it's 2 times 3, which is 6, times 2, which is 12. And this is my final answer, 12 ohms. Okay? Next, 19. Two resistors in series. The cell has negligible internal resistance. What is the resistance of P? So now they gave me the current. Yeah. So I'm going to use Ohm's law. V equals to IR. The total voltage is 1.5 volts. The current, the total current for the whole circuit is 0.2. And the total resistance is the value of P plus 5 ohms. Okay, so you press your calculator. P equals to 1.5 divided by 0.2, and I have to take away 5. And I will end up with an answer of 2.5 ohms. Okay, so the whole idea here is that you have to know how to apply Ohm's law here. Okay, very important, Ohm's law. Last question is about practical electricity. I've got a kettle of such power used 15 minutes a day, and this is the cost per unit. And how much will it cost to use this kettle for a week? Okay, so first of all, you have to know that one unit actually refers to kilowatt hour. So I've got to convert all this information into kilowatt hour. I'm going to start with kilowatts. So 1500 watts is actually equivalent to 1.5 kilowatt. Okay, divide by 1,000. And to add in the hour, I have to multiply by, well, not minutes, I have to multiply by kilowatt. So the energy is therefore 1.5 kilowatt multiplied by the time. 15 minutes, I have to change it to hours. Okay, so press your calculator and you'll end up with an answer of 0.375 kilowatt hour, right? So I've gotten my kilowatt hour, but this is only for 1 day. So I have to calculate the energy for 7 days because there are 7 days in a week. So I have to take 0.375 kilowatt hour multiplied by 7 days. And I'll have 2.625 kilowatt hour. Okay, so if they say that 1 kilowatt hour is 7 cents, 2.625 kilowatt hour is how much? So I got to take 2.625 multiplied by 7 cents, and I'll end up with about 18 cents. Yeah, so this is my answer for question 20. Okay, so same thing. Anything you're not sure, please email me your questions, and then I'll try and go through them as and when I can. All right, so next up, I'll be going through paper 2. Yeah, hopefully my explanation is clear for you.